In this video, we're going to provide an overview of how we can use Tecton to materialize data both to and from Snowflake, and make the resulting features available for model training and prediction. In this example, our data will come from a Snowflake data warehouse. Tecton will automatically orchestrate a feature pipeline that serves data to training models and models in production to power real-time ML applications like fraud detection, recommendation systems, or dynamic pricing. Before getting started, we'll need to make sure that we have the latest version of the Tecton CLI. In a terminal window, we can run the command pip install Tecton Snowflake. Once the installation is complete, we'll need to log into Tecton by running the command Tecton login. This will redirect us to the Tecton web UI, where we can verify our credentials. In Tecton, workspaces are environments that manage collections of feature pipelines and services. We can create our workspace by running the command Tecton workspace create tutorial workspace. In Tecton, features are defined declaratively in Python files that are commonly backed up by a Git repository. To begin developing our feature pipeline, we can create a new repository by running the command Tecton init to initialize the repo. In a Python environment with Snowpark, we can create a new file and name it repo.py. Our pipeline will need to know which data it should ingest. To accomplish this, we can create a new batch data source in our Python file. Snowflake config will define the Snowflake database and schema that data will be pulled from, as well as the table or query within the schema that will be used. In this example, we're interested in modeling customer behavior. We can configure this by defining an entity. Entities in Tecton can refer to products, users, transactions, or any other business objects that we might want to include in our features. Entities are uniquely identified as a join key, which typically maps to a primary key from their original data source. They will eventually allow us to merge data from disparate sources, allowing joins to occur between Snowflake tables or between a Snowflake table and a data source outside your warehouse, such as a data stream. Next, we can start defining the specific data that we want to provide to our model. In Tecton, feature views describe the transformations that we will apply to our data from Snowflake or other data sources. Here, we're creating a feature view called transaction location. The @batch feature view decorator determines data configurations, aggregations, transformations, and metadata that we'll need to successfully use this feature view. We can also tell Tecton where we want to store our feature views. By setting offline equals true, Tecton will materialize the resulting transformations in offline store tables in Snowflake to generate training data sets. Setting online equals true will push feature views to an online store in Redis or DynamoDB for low latency, high throughput retrieval at serving time. The Python function definition allows us to write SQL code to extract data from our data sources at each materialization interval. Our last step is to define a feature service. In Tecton, feature services group related feature views together so that they can be accessed with a single API call. We've now built a complete feature serving pipeline in Tecton, but before we can actually access our data, we'll need to return to our terminal window and run the command Tecton apply. Doing so will push all of the changes in our repo to Tecton and begin the materialization process that will generate and update our feature views in Snowflake, Redis, and DynamoDB. We can see our newly defined Tecton objects in the Tecton web UI. First, we'll need to find our workspace from the Workspace Selector dropdown. Next, we can make sure that our data source is available by navigating to Sources on the left. The same applies for entities, feature views, and our feature service. We can also check in on the status for our new feature service, the Snowflake SQL commands and UDF jobs that Tecton automatically created and ran to materialize them, and each job's status. Once our data has been materialized, our live models can use simple curl requests to fetch feature vectors from the online store at very low latency. And we can also write Python scripts to fetch historical data from the offline store for model training. In just a few minutes, we've created our first data pipeline using Tecton. In the future, we can use the same general pattern whenever we're creating feature pipelines in Tecton. We'll use the Tecton CLI to manage changes to our repo, we'll define our feature pipelines using Python, and we'll use Tecton's web UI to check the status and progress of our pipeline.